Welcome to our explainer. Today, we're diving into something that looks complex, but is actually beautiful in its simplicity. We are decoding the secret language of chemistry.
Okay, let's just get right to it. Have you ever seen something like this? It looks like a bunch of gibberish, right? A jumble of letters and numbers that might as well be some kind of alien code. It's intimidating. But what if I told you that's not what it is at all?
See, this isn't a code you have to crack. It's a sentence. It tells a story, with characters and a plot and everything. And today, we're going to learn how to read it. By the end of this, you'll have the key to understanding this entire language.
So, here's how we're going to do it. First, we'll talk about this idea of chemistry as a language. Then, we'll meet the basic building blocks, the alphabet. After that, we'll see how they form words, and finally, how those words create sentences or equations. By the end, you'll be reading it. Sound good? Let's go.
Okay, so this is the big idea for today. Think of chemistry not as a bunch of math problems, but as a language. It has an alphabet, it has grammar, it has sentences, and once you learn the rules, you can become fluent.
So, where does any language start? With its letters, right? Its alphabet? Well, in chemistry, our letters are these fundamental little particles called ions. These are the absolute basics.
So what exactly is an ion? It's pretty simple. It's just an atom that has an electrical charge. That's it. It's not neutral. And it gets that charge by either gaining or losing these tiny things called electrons. That charge, that is everything. It's what makes the whole system work.
And really, it all comes down to two types of ions. You've got your cations. I want you to think of these guys as the givers. They give away their negatively charged electrons, and because they've lost a negative, they become positive. Then you have the anions. They are the takers. They accept those electrons, and by gaining a negative, they become negative. Givers are positive, takers are negative. That's the deal.
Let's look at a few examples. So sodium, that's Na+, has a +1 charge. It's a giver. But then you have magnesium, Mg2+. That little 2 means it's a +2 charge. It gave away 2 electrons. On the other side, the takers, you have chloride, Cl-, which is -1, and oxide, O2-, which is -2. You see that little number? That tells you the power of its charge, and it is so important.
All right, so we've met our letters, the ions. Now it's time to start building words, or what chemists call compounds. And just like grammar, there's one simple rule you absolutely have to follow. And here it is. This is the golden rule, the most important thing to remember. The final compound must be neutral. All those positive and negative charges from the ions, they have to perfectly cancel each other out. It's all about finding balance.
Let's actually build one together. Let's make calcium hydroxide. So first we pick our ions. We've got calcium, which has a +2 charge, and hydroxide, which has a -1 charge. Now, how do we get them to balance? Well, to cancel out that +2 from the calcium, we're going to need 2 of the -1 hydroxides, right? That gets us to 0. So when we write the formula, CaOH2, that little 2 outside the parentheses is just telling us, hey, you need 2 of these hydroxide groups to make this thing work.
Let's do a few more quick ones, just so you see the pattern. Magnesium is +2, so it needs 2 chlorides, which are each -1. Boom, MgCl2. Okay, what about potassium, which is +1, and sulfide, which is -2? Well, now we need 2 of the potassiums to balance out the one sulfide, so K2S. And then you get a trickier one, like aluminum oxide. You've got a +3 and a -2. The magic number is 6, so you need 2 aluminums to get to +6 and 3 oxides to get to -6. See? The goal is always the same. Find that perfectly neutral balance.
Okay, we have our letters, we know how to build words. Now for the fun part, writing full sentences. In chemistry, our sentences are called equations, and they tell the story of a chemical reaction, what you start with and what you create.
So let's start with a story told in plain English. This is a classic reaction. You take an acid, hydrochloric acid, and you mix it with an alkali, sodium hydroxide. When they react, they produce plain old salt and water. That's the plot of our story. Now, let's look at the characters, our ions. On the left side, we start with hydrogen paired up with chloride and sodium paired with hydroxide. But then, during the reaction, they all swap partners. It's like a dance. Hydrogen grabs hydroxide and makes water. Sodium grabs chloride and makes salt. Everyone ends up with a new partner.
Now there's just one last little bit of detail we need for our sentence.
Chemists use these little symbols in parentheses to say what state each chemical is in. You'll see S for solid, L for liquid, G for gas, and one you'll see all the time, AQ for aqueous, which just means it's dissolved in water.
And here it is, the whole thing, our complete chemical sentence. You can actually read this now. It says, aqueous hydrochloric acid reacts with aqueous sodium hydroxide to produce aqueous sodium chloride and liquid water. See? Every single part of that has a meaning. And now you know what it is.
So there you have it. In just a few minutes, we've gone from individual letters to making words to writing complete sentences. We've learned the grammar that chemists use to write the stories of the world around us. Okay, so let's go back to that monster from the beginning. Look at it again. Does it still look like alien code? Or can you start to see the pieces? Can you see the words in there, the state symbols? Can you see the shape of a story?
I bet you can, because this is the exact same kind of story we just told. It's an acid reacting with an alkali to make a salt and water. The characters are just a little different. And those big numbers, like the 2 in front of NaOH, that's just more grammar, making sure the story is balanced, so no atoms are created or destroyed. That's it. You can read this now. You've cracked the code.
And this is why this is so cool. This isn't just about passing a test. You've just learned the basics of the language that describes, well, everything. It describes baking a cake, a rocket launching into space, and even the reactions happening in your own body right now. The stories are all around us, written in this language. The only question left is, what story will you read next?